Hey everyone, and welcome back to the channel. Today, we're diving deep into a piece of technology that you probably have in your computer, your phone, and even your car, but might not fully understand. We're talking about the GPU or graphics processing unit. Now, you might hear graphics and think it's just for making your video games look pretty. And while that's where it all started, the story of the GPU has become so much bigger. It's the unsung hero behind some of the most exciting technological revolutions of our time, from artificial intelligence to scientific research. So, buckle up as we explore how this specialized processor went from rendering pixels to literally accelerating the future of computing. To really get what a GPU is, we first need to talk about its older sibling, the CPU, or Central Processing Unit. Think of the CPU as the brain of your computer. It's a brilliant, super fast generalist. It can handle a wide variety of tasks, one after another, at incredible speeds. If you give a CPU a complex list of instructions, like calculating your taxes or loading a web page, it will execute them sequentially with amazing efficiency. It's like a master chef who can perfectly prepare any single dish you ask for, no matter how complicated the recipe. It has a few very powerful cores, each capable of tackling complex individual problems. But what happens when you don't need to cook one complicated dish? What if you need to cook a million simple hot dogs? All at the same time. That's where our master chef, the CPU, would start to struggle. And that's exactly where the GPU shines. The GPU is a different kind of beast altogether. It's a specialist. Instead of having a few powerful cores, a GPU has thousands of smaller, shimper, rock. It's not designed for complex, sequential tasks. It's designed for one thing: massive parallel computation. Imagine instead of one master chef, you have an entire army of line cooks. You can't ask any one of them to prepare a gourmet meal, but you can ask all of them to chop one onion each. In an instant, you'd have thousands of onions chopped. This is the core principle of the GPU. It breaks down a huge, repetitive task into thousands of tiny, simple tasks and assigns one to each of its cores. They all work at the same time, in parallel, and the result is a massive speed-up for certain types of problems. This parallel processing power is exactly what's needed for graphics. Think about the screen you're looking at right now. It's made up of millions of tiny dots called pixels. To create an image, the computer needs to decide the color and brightness of every single one of those pixels. And for a video or a game, it needs to do this 60, 120, or even 240 times every single second. This is a monumental but highly repetitive task. Each pixel calculation is relatively simple, and it's independent of the other pixels. It's the perfect job for a GPU. The CPU tells the GPU, here's a 3D scene. Now go figure out what it looks like from this angle. The GPU then deploys its army of cores, and in a flash, every pixel is calculated, and a new frame is drawn on your screen. This is why a better GPU gives you smoother frame rates and more detailed graphics in games. For a long time, this was the GPU's main job. But then, some very clever people in the scientific and research communities had a light bulb moment. They looked at their own complex problems, things like simulating weather patterns, analyzing massive datasets, or modeling molecular interactions, and they realized something. Many of these scientific problems, at their core, were a lot like graphics rendering. They involve performing the same mathematical operation on huge amounts of data over and over again. This was a classic parallel processing problem. Trying to do this on a CPU was incredibly slow. It was like our master chef trying to chop all those onions one by one. But what if they could trick the GPU into doing their scientific math instead of graphics math? This was the birth of what we now call GPGPU, or General Purpose Computing on Graphics Processing Units. In the early days, it was a bit of a hack. Programmers had to disguise their scientific data as things like colors and textures to get the GPU to process it. But the results were so staggering, sometimes showing speed-ups of 100 times or more compared to a CPU that hardware manufacturers took notice. Companies like NVIDIA created a programming platform called CUDA, which stands for Compute Unified Device Architecture. CUDA made it infinitely easier for developers to directly access the raw parallel processing power of the GPU for non-graphics tasks. It was a game changer. Suddenly, the The GPU wasn't just for gamers anymore, it was a powerful tool for scientists, engineers, and This is what we mean by accelerated computing. We're using specialized hardware like GPUs to turbocharge traditional CPU-based systems. And this brings us to the biggest revolution powered by GPUs today: artificial intelligence and machine learning. Training an AI model, especially a deep learning model, is an incredibly computationally intensive process. It involves feeding the model vast amounts of data and performing millions upon millions of matrix multiplications, a type of math that is, you guessed it, highly parallel. It's the perfect workload for a GPU. Trying to train a modern AI model like the ones that power language translators or image recognition software on a CPU alone could take months or even years. With a cluster of powerful GPUs, that time can be cut down 2 days or even hours. Without the GPU, the AI boom we're currently experiencing simply wouldn't be possible at this scale. From the large language models that can write poetry to the AI that helps doctors diagnose diseases from medical scans, GPUs are the silent engines driving it all. The impact doesn't stop there! In scientific research, GPUs are accelerating discoveries at an unprecedented rate. They reused in drug discovery to simulate how different molecules might interact with proteins in the human body, drastically speeding up the search for new medicines. In astrophysics, they're used to analyze data from telescopes and simulate cosmic events like the collision of black holes. In the financial industry, they're used for risk modeling and algorithmic trading, processing market data in real time. In the automotive world, they're the brains behind the advanced driver assistance systems and the self-driving car technologies currently in development, processing data from cameras, LiDAR and radar to make split-second decisions. Pretty much any field that deals with massive amounts of data and requires heavy computation has been transformed by GPU-accelerated computing. So, what does the future hold for GPUs? They're only getting more powerful and more specialized. We're seeing the development of GPUs specifically designed for AI workloads, with dedicated hardware cores for the types of math most common in machine learning. The integration of GPUs and CPUs is also getting tighter, allowing them to share memory more efficiently and work together more seamlessly. We're also pushing GPU power into the cloud, allowing anyone with an internet connection to rent access to supercomputing level power for their own projects, democratizing access to this incredible technology. The line between what a CPU does and what a GPU does will continue to evolve, but the core principle of using specialized hardware to accelerate specific workloads is here to stay. It's the key to unlocking the next wave of innovation. So, the next time you see a new graphics card being announced, remember, it's not just about getting more frames per second in Cyberpunk. That same piece of technology is a direct descendant of the hardware that is helping to cure diseases. Understand our universe and build the intelligent machines of tomorrow. The GPU has evolved from a simple graphics pusher into a fundamental pillar of modern high-performance computing. It is a stunning example of how a solution for one problem can unlock possibilities in countless other fields. It's a revolution that's happening right inside our computers, and it's accelerating our world forward in ways we're only just beginning to understand. Thanks so much for watching today. I hope this gave you a new appreciation for that powerful little chip in your machine. If you found this video interesting, please hit that like button and consider subscribing for more deep dives into the tech that shapes our world. Let me know in the comments what other tech topics you'd like to see covered. Until next time, stay curious.